configurable joint in order to customize my agents and build them so that they can behave in the way that I want them to. So I know that some of you are also starting to work with the configurable joint, so I thought it might be a good resource for me to quickly share some of the things that I've learned from using it. So just to give you guys a little bit of background, what I'm using is a combination of the configurable joint, which is used in a lot of the ML agents examples, and their own joint drive controller that they use in their examples, right? So the reason why I'm using the joint drive controller instead of writing my own code for the setting the position and strength of the joints is because the joints aren't actually, they don't actually work in the way that you would think in terms of physics, right? If you add torque to a joint, it doesn't rotate. That doesn't really work. So you have to treat it like a spring and then force the muscle to go to a position using it as a spring. So there's a lot of quirks there, but I think that the people at Unity have worked this out pretty well. So I'm using their joint drive controller, but I'll go through in a little bit some of the important bits that you should know in order to use this, right? But first of all, what I've done here is I've set up a simple four-legged agent, okay? And it's got each of its four legs has a thigh and a shin and a foot, right? So you can see here on the left, I've set the legs as prefabs, so they are just copies of each other. So all four legs are essentially the same. You may or may not want to do this. So I've set this up this way because I want my agent to walk with joints kind of going backwards instead of forwards. So instead of like think of your knees, think more of like a cat, right? Or a dog, where the joints actually bend backwards in order for them to walk. So let me go through really quickly how I set up these joints. So here's my leg, and then in here I have my thigh, shin, and foot objects, right? Okay. And in each of these, I have a configurable joint that you can see here on the left side. Hopefully you can see this. So basically what we have, so let's start with the thigh. We're going to need to connect it to something. On the prefab, I don't have it connected to anything. On the actual object, I do. This is okay because each one is going to need to be connected to something that doesn't exist in the prefab. But you'll see a few things here. So first of all, there's an anchor, right, which you can auto-configure it. I should probably do this. So it will automatically try to connect the joint based on where it is, and it's also a little bit difficult to see, but there's a little indicator here on top, there you go, that shows you where it's connecting. And those 2 points there, you want them to overlap in order for it to be like a real hinge rotation, right? And then the thing here that is that gave me a little bit of trouble at first are these axes, right? So you have an axis and you have a secondary axis in terms of rotation, and these matter in terms of how your joints are going to rotate, right? So you can see here on the left, if I change my axis, let's say from 0 here, and I put it Y in the 1, it changes its direction, right? So you got to be careful with this. Because you're going to be able to set the joints, let's say the angular motion, I don't want it to slide up and down or anything, I just want it to rotate in some direction. You'll be able to set this, but even if I put here the angular limits, it'll show you like a little sphere, or a part of a sphere where the joint can rotate, but it's not always going to act in the way that you think, right? So in order to combat this and to help me get a better sense of what is going to happen with my agent once I start running it, I built a test script, okay? So in my test script, what I'm going to do is I'm going to take the motion of my joints and I'm going to set them manually and set their strength manually. This way we can get a better idea of what is actually going to happen when the agent gets some input, right? So when they get when they output a certain action, let's say, um, x equals 1 or y equals 1, what's actually going to happen to these limbs? So let me go and show you how this is going to work, right? So I'm going to switch over here to my script. Here's a test motion script. So what I have are a few things. So this here is just a requirement. I need a joint drive controller in order to run this. Okay, this is fine. And you'll notice here also, you'll see these in the ML agents examples. I think these are pretty neat. Here you can just set a header where any of these options, if they're public options, are going to be grouped underneath this header, right? So this is really good for organization, so you don't just have a giant list of public variables. It'll look like this if we come over here. You'll see this body parts, joint controls, right? So you'll see these little headers and then our variables inside. This is really helpful. Okay, so coming back over here, you'll see what I put in here are the transform of all my body objects, right? So in this case, I have 4 legs. So these are the front legs, thigh, shin, and foot, thigh, shin, and foot for front right, front left, rear right, and rear left. All of my my body parts are here. Anything that I want to control the joints of, right? So I guess in this case, the body isn't necessary. It doesn't have a joint control, but we might need it for later when we actually make this into an agent. So you'll notice we don't need to have the agent class yet because we're not actually going to run any learning algorithm on it yet. Okay, so the important things here, I want to control all 4 of my limbs at the same time and for them to all do the same thing. So I've set this up in a very simple way where the thigh X will be the X direction, controlling the X rotation of the thigh, controlling the Y rotation of the thigh, and then for my shin and my foot, I actually have it locked so it only has X rotation. So if you guys are making an agent that has X, Y, and Z rotation, you can definitely just add in here. So if I wanted my thighs to also rotate in the Z direction, I would just put here thigh Z, and then I would in my thigh or whatever it is I want to control, this angular motion for Z, I would change it from locked to limited and then give it a range, right? You would give it a range down here, just like you guys do. So, okay, so going back, let's go ahead and, so I'll go ahead and remove this for now. And the last thing here I have is strength. So this is going to be for my joint strength. And this is important because we need to know, all right, so how exactly does the strength affect the motion, right? So coming down here, it's very simple. So what we do is we have our joint drive controller of our object, right? So in my case, this is my body. It has a joint drive controller on it. So this is going to access that. And then for each one of these body parts, I want to add them to a dictionary, right? So my joint drive controller will set up a dictionary and it'll contain all of my body parts that I put in here. You'll see here I have 4 groups, 1 for each leg, and I put everything in there. Now, once it sets up this dictionary, there's things that you can do to it. For example, you can set the target rotation, you can set the strength of the joint, and this is going to be really important for the actual control, right? So you'll use a lot of this code again in your agent script, right? It's good to keep this test script separate, I found. So keep this as a separate script for testing, separate from your agent that you're actually going to run, because you might need to go back to it, right, if you want to make changes. So down here is the update, what I want to do here in every frame. So this is simple. What I'm going to do is for each body part, I'm going to set the target rotation to a certain X and Y for my thighs. The 0 is because my Z is not controlled, so it's just 0. For my shins, I'm going to control only the X rotation. and then for my feet, the X rotation, right? And then here at the end, I have a loop, okay? I want to loop over inside this dictionary. Remember my body parts dictionary that was created when we did set up body parts? Well, all of my joints, I want them to have the same strength. Okay, this is just for testing. When you actually run this in learning, you're going to want each joint to have different strength, right? You want your agent to be able to control this. So this is fine, but this makes my code a little bit shorter here. So I'm just going to take each body part in my dictionary, in all the keys of my dictionary, right? Everything that can go in here. And then I'm going to set the joint strength to my value, strength, right? So this is really short, really good code that we can implement quickly in order to test the agent and make sure that it has the capabilities that we need it to have. And I'll give you an example right now of why this is needed, right? So let's say for my thigh, if I go to edit angular limits, it looks like, okay, it looks like the thigh can move to the right and to the left. That's my Y. And it can also move here in the X direction. It can move forward and backward, right? So it looks good, and you might think this is the range of where it can move, and this is the range. Like my thigh will actually move anywhere in this little piece of a circle that we have, but that's not actually the way it works, right? Because let's try this out. So on my body, I have my test motion script, and I have all of the transforms of my body parts already in here. And so here you can see the thigh, the joint controls that we've set up. So thigh controls, shin, and strength. Sorry, shin, foot, and strength. Okay, so I'm going to start this, and you'll see immediately. Oh, sorry, one last detail here is that my agent is actually not going to fall to the ground. So everything should be, in terms of the rigid body, should have gravity, but only my body, I'm going to set it to kinematic. That way it can't fall to the ground because I want it to float so that I can see exactly how this is going to move. All right, so coming in here, I'm going to start this out. And you'll see that the joints they'll start to bend, okay? And the reason why they bend like this right in the beginning is because initially all of my controls are set to 0, and 0 is actually the midpoint of anywhere of your range of motion, right? So this is a good time before we get into actually controlling it. What is actually going on in the joint drive controller? So let's move over here and kind of see. There are two main things that we're using. One is set joint target rotation. This is going to be, you give an X, Y, and a Z rotation, right? And so what it's doing is this little transformation of what you put inside is going to take your value anywhere between -1 and 1, and it's going to reset the range here from 0 to 1. So -1 to 1 will be your range, okay? And this is good because you can have, if you think about your joint, the range of motion, it can go backwards or forwards, right? So this is good, but it's -1 to 1, so this is a really good like normalized value. And so all it does is it sets the target rotation. This interpolation function is just taking whatever your float is, let's say 0.5 or let's say 0. It's taking whatever your value is, and it's finding, okay, if it's 0.5, that's 50%. I want 50% between my lower limit and my upper limit, right? So it's doing these for each of these. Okay, so that's the important part here. And then it's setting it using the Euler angles, right? Okay, so the other thing that we're using extensively here is this set joint strength. Okay, you'll see this has the same format as these X, Y, and Z functions up here. So my float for strength is also from -1 to 1, right? So I think it might be a little bit better to use this from 0 to 1, but I've left it as is because it still works well, and I understand how it works now. And then this is just multiplied by whatever your force limit is, which you set, right? So we have here, what it'll do is it will take in the values that you have on your joint drive controller for the maximum spring, the dampener. The dampener is just pretty much in your spring, how much does it kind of oscillate around, right? So even if you have a really strong spring, it will kind of oscillate back and forth forever. You want this dampener to lessen that, right? So when it gets to a position, it stays there instead of wiggling. And then the maximum force is what we're calculating. And then it's setting that for the joint slurp drive, right? So these are the two things that we're using a lot, but the important thing is these are all from -1 to 1, okay? So coming back in here, if I put in here anywhere between -1 and 1, I'll be able to see on my agent what exactly moves, right? So if I put here -1, you'll see, okay, the legs go all the way up to here, okay? Oops, I put, okay, 1. Or if I put -1, all right, they go all the way to the back, right? So they'll go in here. So this is the range. So looks like this is excessive. I probably don't want the legs to go this far back. So so I'm going to want to change this, right? So that's good, but let's go ahead and test the other one. So if we go in the Y direction, this is where we're going to see a problem, right? This is a problem that I initially ran into. Is, remember, initially we thought, okay, I'm going to put this back to 0. Initially we thought if we go to the thigh and I edit the angular limit and we look at this, it looks like it moves to the right and left, but it doesn't actually. It actually rotates, right? So it's actually doing, what I would think of as Z rotation here. So you can see that now when you're actually using this test. When I go to Y1 and -1, it's rotating, right? So it's not doing what I want to do. So what you can do is you can go in and you can change. Sorry, here in my thigh, you can change your axis or your secondary axis. So let's say I change my secondary axis to Z, and this will actually change my angular limits. So you can't see this here, but if I change this to Z, so now this is going to mess up a little bit because I've only done this on one part of the body. So now my right leg is going to be a little weird, but you can see what happens if you make changes here, right? Let's say my thigh, my Y direction, I'm going to put real small value, 0.2. Oops. 0.4. Or maybe I didn't change this yet. Let me come back here. My thigh value. Okay, I've changed this. Let's try changing this to instead what we're going to do is we're going to change this right here to Y, okay? So we can try this and see what this does. So if I go back to my body now and change my Y to 0.2, 0.4, so you can see something is happening now, but it looks like it's quite stuck. So it looks like it is actually moving, right? But that's not what I want either, right? So this is just to show you guys that this is how I've been testing out the joints, right? To see if they do what I want them to do, okay? So coming in here, I'm gonna set this back for now so it doesn't do anything too weird, okay? Like that. Okay. So, so the other thing I want to go through here is like the shin and the foot joints, right? So here you can see for my shin, if I set it, to -1 and 1, and here you can see that even if I put 2 or 15, right, or whatever value, 1 is the maximum it will take. So it's good when you set up your agent also to consider this, because the input can be anything, right? It can be 500, right? Your agent might put in an action of 500, but that doesn't actually matter. So you might want to normalize this in your reward system to set only take aim for actions that are between -1 and 1. Those are the meaningful values, right? And then, of course, we have feet. Who knows if we're going to do anything here? It looks like not, right? So the last thing here is strength. You might want to play with this. What I found for this while I'm just dangling here is the strength won't be affected too much. So if I do something like 0.9, you still won't see a difference. But once I go to like 9, almost -1, which is the minimum, then you'll start to see a little difference. All right, the strength is a little less. They'll start bouncing around. And if I put another 9 in here, all right, now they lose all their strength, right? So this does actually do something. Just in this case, we don't have any force that's resisting it. So so they dangle pretty easily, right? I mean, so they'll always float pretty easily. So you can just use this to kind of test through your joints. This is what I've been doing. Lastly here, I want to talk a little bit about, so it didn't happen right now on this joint, but I've done it before where my joint will start wobbling around really crazy. It'll start to look like it's disconnecting. I might be able to do this. So if I, change this over here to 1 again, we might be able to break it. If I put this to 1 or -1, there you go. You start getting this weird motion, like it can't handle what's going on, right? And even if we turn this off now, it's going to keep doing this weird stuff. So one of the reasons for this is that we should have our joints to be parented to one another. If I move my thigh, I necessarily am moving the shin, right? So my shin should be within the thigh. But if I do this, okay, if I do this, what I'm going to do is I'm going to open up my prefab. And I've tried this before, so just so in case you guys run into this issue, this is what's happening. What I did initially, I was like, well, my shin should be a child of my foot, because if my shin moves, my foot should come with it, right? And then my thigh should be a child, sorry, my shin should be a child of the thigh, right? So if I do this like this structure, this is right in terms of mechanics and in terms of moving it, but visually it's going to do some weird stuff because my scaling is kind of weird, right? So just really quickly to show you this, because I'll send you guys some other examples where I'll have the mesh separate from the actual joint, and this is the reason why. If we play this again, so now I won't have this issue with the joints moving weirdly, but you see visually it's going to look very weird, right? So this is not what I want in terms of how my agent should look. So you'll see it looks very warped, right? So this is because my joints here are scaled strangely. The children are scaled not 1-to-1. So I can go through this with you guys later on, but this is basically happening. The way to fix this is to put these objects inside some empty objects that are scaled to 1, right? So let's go and open this. Sorry, I'm going to stop. It's right here. So if I went back in here into my prefab, for example, if I put my shin inside an empty object, right? So this is my shin parent. And then I put my shin inside here, okay? Well, my shin parent is scaled 1-1-1, so it won't have this issue, right? So it's just a weird Unity thing. You guys might want to look into this, but we can talk about that later. For now, I wanted to really focus on a way to test the different joints and then see their limits of their rotation. And so it gets a little bit difficult, but you can work on one joint at a time and test it out thoroughly to see what's the range of motion and what will it do when it receives input actions.